My name's Tim Lount and I head up the sales and marketing for the consumer division of Tannoy. So that's really anything to do with loudspeakers that you may use in the home for hi-fi and home theatre. There are 5 loudspeaker models in Tannoy's Revolution XT range, 2 bookshelf speakers, a compact model based on a 4-inch driver, and then there's a larger 6-inch bookshelf as well. We have 2 floor standers, one based on 6-inch drivers and the other, the largest model in the range, based on 8-inch drivers. There's also a center channel for home theatre use, and the design of this model has some particularly interesting features. A plinth with a tilt mechanism, allowing fine directional tuning of the angle of the drive unit towards the listener. The size of drivers that we use in our speakers is typically related to an acceptance that most consumers have a logical limit to the size of speaker that they can fit in their rooms. At the entry level to mid part of our speaker range, we tend to use 6 to 8-inch drivers because we aim to create as slim a cabinet as we can to accommodate the driver and of course get performance within any given volume.
I'm Dr. Paul Mills and I've been working for Tannoy for over a quarter of a century now, in which time I've been responsible for voicing and designing our residential loudspeakers. Tannoy first patented the dual concentric loudspeaker in 1947, and it really is quite different to a typical coaxial loudspeaker. That's because the tweeter is set back at the acoustic centre of the low frequency driver, not simply in the middle. This enables us to achieve pretty well a perfect point source. Having a coherent point source maintains symmetrical dispersion and phase coherence throughout the audio band, including the critical crossover region to the low frequency cone. Now this gives us accurate point source imaging even off axis, and also maintains the true harmonic relationship of musical instruments. With the new Revolution XT series, we have a completely new design of dual concentric. It uses an Omnimagnet system to enable a better optimised mechanical arrangement. As it implies, there is a signal magnet for both sections, hence the word Omnimagnet. Now this is necessary for the new waveguide system to operate, and it also has the benefit of increasing power handling. The polymer HF dome is torus, donut-shaped, allowing it to be placed further towards the front of the driver. The O-drive, bullet-shaped waveguide, sits in front of the diaphragm, which assists in shortening the propagation path of high-frequency waves. Now this torus O-drive structure, as we call it, allows a faster expanding flare than previous tulip-shaped dual concentric waveguides. The HF wavefront then propagates over the cone surface of the bass driver, which is shallower than previous designs, again helping to widen dispersion. This results in a shortened acoustic path through the drive unit and greater phase coherence between the HF and LF sections. Now, the new torus O-drive waveguide has really profound positive effects on stereo imaging. The wider dispersion compared to our earlier tulip waveguide gives greater phase coherence and ensuring a natural and more expansive sound. In addition, the increased power handling and thermal efficiency of the Omnimagnet motor system enables high sound levels, allowing the full dynamic range of the music to be realised.